Alrighty, so yesterday we began talking about this concept called energy. Remember that we said energy is the ability to cause change or the ability to do work. It's the same thing. We said that we compared and contrasted work and energy here, like we did here. And then we looked at the different ways that we can transfer energy. Remember, if work is done, then energy is transferred from one system. We had a new concept yesterday also called system. When one system does work on another system, energy is transferred from one system to another. Remember that a system could be just one object, like a baseball bat, or it could be a group of objects, like a solar system. All right? So systems do work on one another, and when they do that, they transfer energy. That's the same thing I just told you. All right, then we talked about some different forms of energy that we are going to explore, and the main two types are KE, or kinetic energy, the energy of motion. We talked in depth about that one yesterday, and today we're going to talk about the second type, which is PE, how I'm going to abbreviate it, which is potential energy, and that's stored energy. We also said we have lots of different littler types of energy. Not littler, but other types of energy, but we're not going to get into those quite yet. So remember I said that we can convert energy from one form, so from any of these forms to any of the others, or from a kinetic energy to nuclear energy, or from potential energy to electrical energy. We have all of these different, we can transfer any type of energy we can convert it from one form to another, just like we can convert coins of money coins, coins with a dollar value or a value to bills with a value, right? It's the same concept. So we can convert kinetic energy to potential energy. We can convert potential energy to kinetic energy. We can convert them to other types of energy, etc. We talked more in depth yesterday about kinetic energy, like I said. Remember, we said that kinetic energy, again, is the energy due to motion. Kinetic energy depends on the object's mass and on the object's speed. And we can see that in the kinetic energy equation that we wrote yesterday. We did several practice problems, and that was your homework, was to do more practice problems. And today, finally, we will talk about potential energy. All right, so energy doesn't always involve motion. We don't have to have motion to have energy or to have work being done. We can have, objects that are motionless, objects that are at rest, can still have energy. And the type of energy that they have is potential energy. Potential energy is the energy that is stored, like I said before, and the energy that is stored due to the interactions between objects. So an example is the energy stored between an apple hanging on a tree and Earth. So let's draw that. All right, so here we have our apple and our tree. So the apple here, the apple has potential energy. The reason that the apple has potential energy is because of the gravitational attraction between the Earth and the apple. There is a gravitational attraction, right? The apple, if it breaks off from its stem, it will fall to the Earth. It's not moving, but it has the potential to move. It has the potential energy, right? And the reason for that is because the force of gravity. All right? So this has potential energy. Does not have no kinetic energy. Has no kinetic energy, but does have potential energy. If the apple breaks off the tree and falls, now the apple has kinetic energy, right? All right. When it's in motion, when it's falling, it has kinetic energy, not potential energy. But before it falls, when it could fall, that's when it has potential energy. So we have a couple different types of, two specific types that I really want to focus on of potential energy. We have, let's write this here. two types of potential energy we're going to discuss. They go over three in your book, but we're just going to go over two. We're going to go over the chemical potential energy, and we're going to go over gravitational potential energy. And this is GPE in your book. That's how it's written in your book. Okay, but first let's do chemical potential energy. All right, so the definition of our first one, chemical energy, is it is the energy due to chemical bonds. So some examples of things that have chemical potential energy is food that we eat, gasoline that we put in our car. These are both, in their own way, they contain chemicals. Food contains chemicals. Gasoline contains chemicals. Chemicals have chemical bonds that hold atoms together. So we might see this chemical potential energy, because it's really hard. It's not, we can't see, if we just see gasoline, for example, or what can we say? Let's say, now we'll use gasoline. When I just see a gallon of gasoline, we don't see any energy coming off of that, right? Well, of course we don't, because it's potential energy. It's chemical potential energy. So if we just have a gallon of gasoline here, and we're not doing anything to it, and it's just filled with gasoline, nothing's going to happen. We don't see any energy. There's no energy transfer occurring. But if I were to spark a chemical reaction, for example, if I were to burn this gasoline, then that potential energy, the chemical potential energy, would be transferred into thermal potential energy, which is also like an example of that would be fire. So the gasoline would light on fire, right? So this would be a transfer of the chemical potential energy stored in gasoline to thermal energy, which was one of our types of other littler, and I keep calling it little, but it's not little energy, are different other types of energy that we'll talk about later. We transfer it into thermal potential energy. So this is just one example. Food, an example of food, is all food. Is it all food? I would say yes. Food has something called glucose, which an easy way of saying that is sugar. Not sugar not like sugar that you put in tea. It's a chemical. It's a different type of sugar. Okay, so like the apple example that I was talking about yesterday, when I eat an apple, I transform that sugar that's stored in the apple, I transform that into energy. That is what, and then my muscles use that energy that they basically suck from the chemical bonds in the apple. They use that energy to move. I use it to contract my muscles to move around. So this would be sugar to muscle movement, which requires energy. So we transfer the sugar into the chemical bonds in the sugar molecules. We transfer that energy, chemical potential energy, into movement, which is kinetic energy, right? So we're transferring chemical potential energy into movement in the case of food. In the case of gasoline, we transferred the chemical potential energy here into thermal energy, right? So that's just two examples of what we can do with chemical potential energy. All right, so that's what you need to know for chemical potential energy. For gravitational potential energy, this is the one that we're going to use more, and we're going to actually have an equation for this one. So gravitational potential energy is the energy that is due to the gravitational forces between objects. So this is the energy due to gravitational forces between objects. All right. Okay, so an example of this was our apple up here, right? Before we had the apple, before we had the apple falling, right? Before it fell out of the tree, when it was still stuck to the tree, this apple has potential energy, I told you. Well, the type of potential energy that it actually had was gravitational potential energy. Remember? Because I said the earth is pulling the apple towards the ground and the apple is pulling it towards it, the earth towards it, but the stronger force is the earth pulling the apple towards it, right? So this is actually gravitational potential energy. It's the energy that is there due to gravitational forces between the objects. All right, so we are going to have an equation to solve for gravitational potential energy. Remember that all objects attract one another, right? But we're going to be mostly looking at the Earth attracting objects from a distance, right? So the Earth is going to cause this apple to fall. The Earth would cause, if I had my pencil, like the other example I gave you, if I have the pencil sitting on, this is my desk, and this is my pencil. If the pencil is sitting on the edge of the desk, it has potential energy because the Earth is pulling. It has gravitational force with the pencil, right? So if a little bit, if something were to, if the desk were to get bumped, for example, that pencil would fall to the ground because of gravitational potential energy, okay? So our equation for gravitational potential energy is gravitational PE, and I'm going to abbreviate, well, this is going to be in the units of joules because it is energy, right? Gravitational potential energy equals, let me erase my desk and my pencil over here. It equals mass, and of course the units for that will be in kilograms, mass times gravity. And remember from earlier, we know that gravity on Earth is going to be equal to 9.8 newtons per kilogram, right? But we're going to see that we're not only going to deal with gravity on Earth. We're going to have, we can have gravitational potential energy with objects falling from an imaginary tree on an imaginary planet with a different gravitational force than Earth's, right? So I'm not going to write that this isn't a constant. It depends on the planet that we're on, or the object, the body that we're on, because it would be different on the moon as well, okay? We're going to do some practice problems with that. So we got mass times gravity, and that is times height. This will be in meters. And height is, another way of saying this is how high up the object is from whatever base or floor that you're measuring. So we're going to see that more in our next examples or in our practice problems as well. So how do we abbreviate this whole equation? Well, that will be GPE, gravitational potential energy, is equal to mass times gravity times height. Mass times gravity times height. All right. So this is our equation for potential energy or gravitational potential energy that we're going to be seeing over and over again. So let's do some example problems now using that equation. All right. So here we go. Our first example problem. We have a 4.0 kilogram ceiling fan, and it's placed 2.5 meters above the floor in a room. What is the gravitational potential energy of the ceiling fan? And I wrote here relative to the floor. So let's draw a really quick picture to understand why I need to say relative to the floor here. So let's say that this is our house, okay? And we have 2 floors. So here's the first floor right here where the door is. And on the second floor is where we have this ceiling fan, okay? So I want to know what is the gravitational potential energy relative to the floor right here. I need to specify because the height is going to be this 2.5 meters. But I have to specify to the floor here, because which floor am I talking about? Am I talking about the second floor? Am I talking about this first floor? Am I talking about the center of the earth, right? Which would be, this would be a different distance. The center of the earth would be a different distance, etc., etc. So when I say relative to the floor, I just want you to know that means that I'm talking about the floor in the building. Not the floor outside, or the floor in the first floor, or the third floor, whatever floor we're on. It doesn't specify in the question. And I'm not talking about the surface of the earth. I'm talking about what is the gravitational potential energy of the ceiling fan relative to the floor. All right. So let's write our knowns, unknowns, and equations. Okay. So first of all, we know a mass of 4.0 kilograms. And we know a height of 2.5 meters. We want to know the gravitational potential energy. I know that gravitational potential energy equals mass times gravity times height. I don't have to rearrange for anything because it's already arranged for me. So I'm going to have GPE is equal to... Oh, I also have one more known that I didn't write over here. So since we're on Earth, I'm not being explicit about us this ceiling fan in this room being on the moon, right? I said if I don't say we're on a different planet with a different gravitational gravity strength, then just assume that we're on Earth, okay? So what is the gravitational strength? What is G on Earth? Well, we know this is 9.8 newtons per kilogram, right? That we know that from this equation. Remember when we were doing the force of gravity equation? So we know that from there. It's going to stay the same. Okay, so we have everything we need to solve for this. We have 4.0 kilograms is our mass times a 9.8 newtons per kilogram gravitational strength times a height of 2.5 meters. So when I plug that into the calculator, I get 98, and my units here, let's see what happens. We have kilograms canceling kilograms, so I'm left in newtons times meter. Well, that's not how I express energy. I'm not going to write it in newtons times meter. I'm going to write it in joules. Remember that 1 newton meter equals 1 joule. Remember that from, I don't remember, that was section 4.1, I think. And I went over it yesterday. So we have 98 joules would be our answer there. All right, let's look at another one. All right, so now we have an 8 kilogram textbook sitting on a desk. So here's our book, and it's sitting on a desk. The desk is 1.25 meters tall, and the book has a mass of 8.0 kilograms. So an 8 kilogram textbook is placed on a 1.5 meter high desk. What is the gravitational potential energy of the textbook? And of course, I'm asking you this in relation to the floor. Okay? So our knowns, our unknowns, and our equation that we're going to use. We have a mass of 8.0 kilograms. We have a height of 1.25 meters. We know our gravitational force or strength, because I didn't say we were on a different planet or the moon or wherever, is 9.8 newtons per kilogram. We're looking for gravitational potential energy. Our equation is GPE equals mass times gravity times height. We don't have to rearrange because we have everything. So we can just plug it in and solve. We have GPE is equal to mass, which is 8.0 kilograms, times gravitational strength, which is 9.8 newtons per kilogram, times the height, which is 1.25 meters. When I plug that into my calculator, I get 98, and my units there and there cancel, newtons times meter, but I know that that actually equals 98 joules. Okay, so what I want to do is modify this question just a little bit. I'm going to rewrite this question, and then we're going to solve it again using some couple adding a little bit of spiciness into it. Okay, so now we have an 8,500 gram textbook, and it is placed on a desk. It's placed on a 1.25 meter high desk on an alien planet. Okay, so we still have the same concept. We have this book with a new mass, and it is placed on a desk that makes it 1.25 meters above the ground. And this is on an alien planet, so not on Earth. If the book has a gravitational potential energy of 212 joules, what is the gravitational strength on this planet? All right, so let's write down everything we know here. We know our mass is 8,500 grams, okay? Immediately, alarm bells should be going off in your head because we see grams, and we know for sure that every time we have a mass, it has to be in kilograms. So what I would do first, before you even write down another one of your knowns, is do dimensional analysis to find out how many kilograms is 8,500 grams. We know that 1,000 grams is equal to 1 kilogram. So we cancel, and we get 8.5 kilograms. Okay, so our mass is 8.5 kilograms. Whew, okay, so we're good. We don't have grams anymore. Now we're going to be using this mass instead. All right, what else do we know? It's placed on a 1.25 meter high desk. So we know the height is 1.25 meters. We don't have to convert that because it's already in meters, so we're good to go. If the book has gravitational potential energy of 212 joules, so we know that GPE is equal to 212 joules. Then we want to know what is the gravitational strength, or G, little g, of this planet. All right, so I think we have written everything that we need. Now we will look at our equation. We know that gravitational potential energy equals mass times gravitational strength times height. The problem is we need to isolate G here. So to isolate G, first what I'm going to do is divide both sides by M. And I'm going to cancel the M there. Well, I also want to get rid of H, right? So I could also just divide by H while I'm doing that. And that will go on the bottom. So I get GPE divided by mass times height is equal to gravitational strength. All right, now we're good to go. So we can plug everything in here and solve. The only thing I would recommend doing is I gave you the potential energy in joules, right? But if you look at all the units that we have meters, we have kilograms, and we know that gravitational strength must be, the units that we must write that in are newtons per kilogram, right? So if I have joules over here, that's going to just mess everything up. So another way of writing 212 joules is 212 newtons times meter, because at least then we have meters and meters here, and we'll have newtons so that our answer will be in the correct units. Okay, so let's solve. If you don't want to convert it to joule or to newtons times meters, that's fine, but it's going to make things more easy for you to make sure that you have the correct units on gravitational strength. All right, so we have G equals gravitational potential energy divided by mass times height. So if we plug everything in here, we're going to use our 8.5 kilograms, not grams. So, first we're going to write our 212 newtons times meters, our GPE. Then on the bottom we'll use our 8.5 kilograms, not grams, and we'll multiply that by 1.25 meters. Okie dokie. So here we will get, when I plug this all into my calculator, we get about 20, And my units, if you see, meters is on top and meters is on the bottom, so they cancel out. And I'm left with newtons per kilogram, just like I wanted up here, right? So I have 20 newtons per kilogram. All right. That is the gravitational strength of this other planet. So rather than being 9.8 newtons per kilogram, like the gravitational strength on Earth, this other planet has a gravitational strength that is about 2 times as strong, 2 times stronger, if you would prefer, as Earth's gravitational strength. Right? Okay. So that's more like the kind of problem you're going to see. I'm going to give you a little more spice. It's not going to be as black and white and straightforward and super easy as plug in these values and solve. Okay? So this one, that's a very good problem. So I would recommend going back over this lecture to look at this again if you are struggling with that. Okay, so that is it for section 4.2. So what you're going to do the rest of the day is work on the 4.2 potential energy problems. And that is on Classroom. And for homework, yesterday I messed up on the notes, I apologize, but I corrected it before any of you got home and realized it, except Ceci. Good job, Ceci. Ceci saved everyone. Go, Ceci, you rock. So for homework tonight, you will read and take notes and submit your notes on section 4.3. And that is what we will start tomorrow. We will also be doing some practice problems tomorrow covering kinetic energy and potential energy. So covering basically 4.2. You're going to do some practice problems, and then if there's time at the end, you will begin watching the part 1 of 4.3 lecture. Okay? So this is due tomorrow. This is due tomorrow. All right. Please let me know if you have any questions. Thank you.